Hi students, this is the second video for work energy and power, okay, the part 2. Okay, so in the previous video we have talked about energy, okay, and there are three particular examples that we're looking at: work done, gravitational potential energy, and kinetic energy. And all the energies, okay, has a SI unit of joules, okay, which is represented by the symbol capital J. Okay, this is the symbol for the SI unit, capital J. Okay, it's joules. Okay, so in this particular video, we are going to talk about conservation of energy. Okay, for conservation of energy, it's a little bit abstract. Okay, but I do hope that this simple example will help you a little bit. Okay, so let's talk about the ball being held at the position at the start. Okay, a ball is being held 10 meters away from the ground. Okay, what do you think is the energy that is present at that moment in time when the ball is being held? Very good. Okay, the ball will have gravitational potential energy. Okay, in fact, we will also know that the kinetic energy is 0. Why is it 0? Because the ball is not moving. Okay, so when something is not moving, there is no kinetic energy. Okay, but when the ball drops, when the ball is let go and is dropped to the ground, we know that the gravitational potential energy will decrease because the height from the ground will change and it will just get lower and lower. So by the time it reaches the ground, where the height is actually 0, okay, by the time it reaches here 0 meters, okay, the gravitational potential energy is now 0. But is the ball moving? Yes, the ball is actually moving, and just before it hits the ground, it has the most kinetic energy. So in this case, we know that the gravitational potential energy has been changed or changes to kinetic energy throughout the whole situation. So in physics, or in an ideal situation to be exact, okay, in an ideal situation, we say that all the gravitational potential energy will be changed into kinetic energy at the end. So what do I mean by that? Let's use some numbers to help you see. If the gravitational potential energy at the start is 500 joules, then when the ball reaches the ground, the gravitational potential energy is 0 joules, but the kinetic energy is now 500 joules. Why is this so? Because all the energy from the gravitational potential energy at the start is now changed into kinetic energy. Okay, so what is all this talking about, or what idea does this stem from? This idea stems from this thing called conservation of energy. Okay, so conservation of energy is a very special principle. Okay, it has two parts. Okay, first part of the principle states that, okay, energy cannot be created or destroyed. Okay, which means that you can't magically produce energy out of nowhere. Okay, neither can it just disappear. Okay, the second part of this conservation of energy states that the energy can only be converted from one form to the other. Okay, so what does this mean? Okay, if you look back at what we have down here, Okay, what we have done, or what we have understand, is that the gravitational potential energy will be changed into kinetic energy throughout the whole situation. Okay, but the energy is not lost anywhere or disappeared or not destroyed. Okay, so this conservation of energy, please go and memorize the two portions. Okay, it's a very important principle. Okay, and we need to make use of it very regularly to answer some questions during your N level or O level. Okay, so this is conservation of energy. Let's try out some examples. Okay, so let's say the ball is launched into the air with the speed of 2 meters per second. Okay, the mass of the ball is 1 kg. What's the question now? Find the height or maximum height which the ball can reach. Okay, so what is the hint? The hint is use the principle of the conservation of energy. Okay, for those who have already tried it, okay, here is the answer. Okay, for those who have not, I hope you go and try it later on. Okay, so like always, whenever you have a question in physics and you can't understand, okay, please draw a simple diagram to help yourself. Basically, this question is trying to tell us that the ball is going to be launched upwards into the air at 2.0 meters per second. Okay, but we know that, or based on what the question says, it's going to reach a maximum height. Okay, which we do not know what is it. Okay, so if you look at the situation, okay, we also know that the mass of the ball is 1.0 kg. So here are a few ways that, or here is one way that you can actually help yourself. Okay, when we use conservation of energy. Okay, so first and foremost, ask yourself a few questions. At the start of the situation, what sort of energy is present? Okay, so based on what you have drawn here, or what we have drawn here, we know that there is kinetic energy at the start. Okay, I here means initial. Okay, ask yourself, is there any potential energy at the start? Okay, we can assume there is 0 here because there's no reference on what is the height from the ground at that point in time. Okay, and after we have done trying to find out what is the energy, or what are all the energies at the start, okay, then we can move on to the final state, which is at the highest point. When the ball reaches the highest point, what sort of energy is there? Yes, there's gravitational potential energy. Okay, I put it as GPEF. F means final here. Okay, ask yourself, is there any kinetic energy at the end? No, actually, there's no kinetic energy at the end. Why is that so? Because when the ball reaches the maximum height, it actually stays there for a while, and when it stays there for a while, it is now stationary, which means there's no kinetic energy. If you do not believe me, just throw your pen up into the air. You realize that the pen will actually pause in the air for a short while once it reaches its maximum height. And that's why there's no kinetic energy. So KEI is now equals to GPEF. What is this actually? This is actually the conservation of energy, because we are now trying to say that the kinetic energy or the kinetic energy at the start will now be changed into gravitational potential energy at the end. So let's input all the values. Okay, kinetic energy at the start is half mv square. M here is 1.0. V square is 2.0 square. Okay, GP at the end. GP formula is mgh. M here is 1.0. G is 10. H is the height that we need to find. After you have filled in all the information, you realize that there is no longer any physics involved. The rest of the steps would just include the mathematical manipulation of this equation. Okay, but anyways, let's just go and work it out. Okay, if you work out the left hand side here, half mv square, m is 1. Okay, so half times 1 is half. Half times 2 square is still 2. 1 times 10 on the right hand side will give us 10. And this will give us height is actually 2 over 10, which is 0.2 meters. Easy? Definitely. Okay, so what do we need to remember? Okay, so in order to answer this sort of question, there are some guiding questions that you might want to ask yourself, okay, whenever you look at such question. Okay, so I will list down some guiding questions for you. First one, what are the energies present at the initial stage? Okay, so like what we have done before over here, what are the energies that are present in the initial stage, which is at the starting? So in our case here, the energies that is present at the initial stage would be the kinetic energy only, but there's no potential energy. Okay, next. Okay, the second question would be, what are the energies present at the final stage? So in our question here, the final stage would be at the highest point. So what are the energies that are present at this position? So in this particular question, the energies that are present will only include gravitational potential energy, because the ball is, when it's at its maximum height, will have no KE. Hence, gravitational potential energy only. Okay, so with these two guiding questions and the conservation of energy, we know that these two will actually equate to each other. So third thing, okay, the third guiding question or guiding point would be, okay, total initial energy is equals to total final energy. Okay, so this is actually our conservation of energy. Okay, I hope this video has helped you understand what does conservation of energy means. Okay, and we'll watch out for the next video, okay, which will be just solely on power. Okay, see you in the next video.